So welcome everybody. I'm Chris Wickman. I've been working with Dr. Vince Giuliano for a couple of years now. And these are some general guidelines. So we have a pretty quick timetable today, but I put that schedule in the chat window. I'll update it again if some of you joined after that. So we're looking for a lively discussion. Please mute your mics when you're not speaking. Raise your hand using the Zoom icon. Keep your comments and questions brief if you may. Feel free to use the chat feature. We are recording the meeting and we'll be editing it. I believe I may be doing the editing if people have questions, and we may take a quick break after 1 hour, depending on if we need to. And here is the current schedule. And again, it'll be posted into the chat window. And with that, I don't know if Dr. Giuliano's been able to join us. We were hoping he would be feeling well enough and have some opening comments. And if not, Walter, you may elect to kick off with Rick or continue some initial chit chat.
I think it might be too many people to have all introductions as much as that. That's a nice
Yes.
formality.
No, yeah, for sure.
But suffice it to say that it's a, for people that aren't that familiar, we're lucky to have some really stellar participants here that are well known in the longevity community. So I'm not going to say very much. I think let's have Stephen get things rolling.
Hey, Walter. I certainly can't replace Vincent. He was such an important part of the early longevity movement, but he's hopefully will show up anyway. We've got a large number of people here who know each other, and we have both the experimental side of the research. We have the theoretical side. Many of you know each other already, which is good. And we're now going to talk about actually applying it in medicine. So we have some MDs that are going to be helping us out with that. Most notably, Dr. Cohen first.
If I may, real quickly. So the idea is the presenters will present their stuff rather quickly, with the idea that we have a long period for questions so that everybody can chat. And I really, beat up all my friends here, challenge them with hard questions, and let's make it so we all walk away with our questions answered. I'll shut up.
Hey, y'all. Looks like we have a nice group. I'm Rick Cohen, MD. I'm physician, engineer, sort of an out of the box translational thinker, and joined up with this group recently. And I want to just sort of set the table, so we all have the same base awareness of what we're trying to achieve and how plasma exchange, plasma replacement, et cetera, fit in. So clearly most people are aware here, obviously, of the parabiosis experiments where the young mouse and the old mouse were linked together. And, without getting into too many details, there were signs of aging in the young mouse and euthanizing, we'll call it, in the old mouse. So clearly there's some factors in old mice, or old as we age, inflammatory signals, we'll call them aging signals, that accumulate. And there are some youth factors that exist as we are younger. So we keep it simple like that. So what do we have? We have out with the old. And, two of the things that I think about that are very clear is iron removal, right? So it's something we're familiar with. Iron can build up in our body 1 milligram a day in men. And over 50 years, you can actually have 20,000 milligrams of iron, which is equivalent to 6 times the amount of plasma or blood that we're carrying in our body. So we accumulate old factors. Removing iron or removing blood is a positive thing. So what options do we have with plasma? We have plasma donation. So there's one where you can actually go, you can donate plasma 600 to 700 milliliters at a time. That's one theoretic option. The other option with the old is plasma exchange, where we're pulling 3 liters up to, and that typically at 3 liters, because you're pulling so much plasma out, you're getting albumin. So that's the out with the old options. The in with the new is I like to think it as young blood factors, right? So there are many of these signaling molecules, and some that I've worked with are GDF11, Clotho. There's E5, that's LL37. There's platelet derived factor 4. So there's all these individual signaling molecules that we're discovering more and more over time. And keep that in mind because one of the arguments of young blood is we don't know all the factors to replace. And that is true. At the current time, we don't. So one of the ideas is just put in young blood, or just put in individual factors and look for their response. So those are options. Then we get to the both, right? And that's one of, well, do you take out the old and put in the new? So that's another option that exists within our framework. Now, the key pieces to think about is sequencing. So, now I'm going to get down to a clinical level. So we have all these different options. You can pull plasma, you can pull blood, you can donate plasma, you can get young blood factors, you could get young blood, or you can do them both. Now, the questions that we need to, and I'm looking forward to digging in more, is how do you sequence this with each person? From some of our individual knowledge, and my experience is some people, there's a large inflammatory burden as you get older. So perhaps throwing in plasma factors initially may not be a good thing until you clear out inflammation. There's sequencing. What do you do and in what order do you do these in? Plasma factors also could play a role because if we just give someone a blanket young blood plasma, we're losing the ability to titrate or individualize. So when we work with GDF11, it's a very controlled, slow titration, and we know each person's threshold for GDF11 is a little bit different. And if we're just giving blanket plasma, we don't know what they're getting. One can make an argument, theoretically, at this time, there's a place for both. Continuing with the same mindset is, are there ways, and I'll be reaching out to other physicians to see what they've experienced, is how do we enhance that experience? Is there ways when we're doing these procedures, is it EWAT, is it PMF, is it HBOT? Are there things that we can do that will actually improve upon the body's ability to replace and repair? Steve Buss is going to speak about something that relates to frequency. So he's uncovered something called the cholinergic anti-inflammatory pathway, and he'll talk about how the effects of plasma exchange correlate or match some of the things we can do at home using devices such as red light or transvagal nerval stimulation or photobiomodulation or hypoxia, hyperoxia. So there's a number of things we could do at home. So theoretically, and anecdotally at this point, and it's all N=1, if you can do some of these things, some of these maintenance protocols, and you can track them in a individualized way, we might be able to lessen our load of requirement of these higher end, more costly, more interventional resets. So that's a piece that still needs to be determined. And other things, where do stem cells, V cells, there are some clinicians that are adding in stem cells afterwards, so that as an enhancement as well. And then I think I'll end it with, at the end of the day, if our goal is age reversal, which is what my goal is, it's going to require a variety of different interventions. plasma exchange could be one of our more powerful ones that we have now that are translational. But as I've sort of alluded to, there are many other pieces that need to be fit in to the puzzle. We can't create, and I use the symphony, and it's part of an industry issue too, uh, is everyone's looking for one particular strategy or protocol to make a difference. And I urge you to think of we're all different. So we all have a different concert piece. While there's certain strategies we all need, there's individual tweaks, sequences, and even interventions that we need to play your own particular music to make this happen. And it will never happen until we can understand how to use that toolbox and actually start to do that in a synergistic, comprehensive way. And that's sort of what we're hoping to achieve or start to achieve in the next 6 months in an offshore clinic and actually begin to do these things and figure things out. So food for thought, and love ideas and other thoughts.
Okay, by way of comment, I'm not sure you all got it, but the idea is to have a relatively short presentation, as Rick just gave, and then everybody raises their hand, and Chris will call on them in order to ask their questions or make their comments, criticize, whatever.
Yeah, and I'll add, if you raise your hand and I don't see it because we're starting to get a number of people, feel free to jump in if I don't catch you. So if there are no comments or questions at this time, but feel free to jump in, then Walter, I'll leave it to you whether we should move on to the next speaker.
Okay, well then I'll just say, so, I really liked Rick's summary there. It seems that there are a number of components in the plasma that can be differentiated and sub-differentiated. So, you might have, say, exosomes and peptides and, salts and all kinds of things. And that part is ultimately, we would probably want to customize that. One of the methods he mentions, of course, is where you take out the plasma and you replace it with saline plus albumin plus maybe a few other factors. But basically, you're removing everything except the albumin and letting your body do whatever it does to restore the missing components. And, I'm sure Dr. Kiprov, he's a real expert in this. He'll probably mention something about that. I don't know. Okay, go ahead, Johnny.
You need to unmute, Johnny.
I think Neil also had raised his hand possibly.
Yes, I'll come in after Johnny.
Johnny, you have to unmute.
Yeah, I'm trying.
You are unmuted. Go, Johnny, go, go, go.
Oh, I am. You can hear me now. Okay, yeah.
Yeah.
Regrets. I just got out of a ophthalmic appointment here at the University of Miami facility. And I just heard the very end of Rick's presentation. Really intriguing. Where would you put in the chat, or someone please email me some in online information about this? And Walt, as soon as you can, make this recording available. I regret that I was unavailable for the first part of it. Go ahead.
Thanks, Johnny. Chris, where is it that you're going to be working off seas? What areas, what countries are you looking at working in?
Rick?
Oh yeah. We'll know in a few weeks, but probably start with Prospera in Honduras. So there's already a setup there we'll have more information. There's some other opportunities as well, but that's going to be the least regulated location for us to begin with, to do a whole variety of different things.
Great. Good luck with that.
A fellow named Kasux on your screen has a mini clinic down there in Prospera now.
Oh, great. Maybe we'll hear from them later in the talk. Would you like to continue now with Neil?
Okay. Thank you. And thank you for inviting me to be here today. I look across the board and see the many names and many people I know, some I don't, but the one thing I am not is a scientist. I'm not a researcher or a scientist, so my presentation is completely different than what you're going to be seeing. I hope that you don't mind. So I just want to give you maybe a little bit of inspiration and ask you, what will you do when death has become optional? The front page of the New York Times reads that the medical researchers at laboratories around the world have reversed aging for people and made death obsolete. What will you do when humanity has found a cure for the disease of aging? The main thing is most people don't believe this is possible. Most people don't believe it's possible to have an unlimited lifespan. But I do. I look at the amazing discoveries and the research and things that we've done as a species, and as a magnificent species we are, I think that we will find a cure for aging. We love to compete. For example, foot races have been held for thousands of years all over the planet. In ancient Greece, there was competitions in the old Olympics to run the mile in under 4 minutes, but they could not do it. The Olympic torch was relit again in 1896 and competitions began anew. Runners raced against the clock and they run in order to beat the 4-minute mile, but they failed. And this went on, and the stagnant experts of human physiology and human endurance of the time came forward to declare that it was impossible to run the mile in under 4 minutes. They proclaimed it couldn't be done, and still runners tried. Some runners would tie bulls behind them to increase their incentive to do what was believed in the time to be impossible. And these self-proclaimed experts said that the human body had reached its limit. Then in the 1940s, the mile record was reached to 4 minutes and 1 second, where it stood for 9 years as runners struggled with the idea that the experts of their day must be right. Then, as we know, in 1954, Roger Bannister came forward to the scene and he broke the 4-minute mile when he ran the mile in 3 minutes and 59.4 seconds. And as a part of his training, he visualized this achievement in order to create a sense of certainty in his mind and in his body. After he broke this invisibly perceived barrier, an interesting thing happened. Immediately, other people began to also run the mile in under 4 minutes. So the barrier that existed for thousands of years vanished. We generally tend to follow and believe the experts of our day. And these stagnant experts in any field learn what they know from past experts who learned from other experts, and this status quo is maintained in every field of discovery, just as it was with running and beating the 4-minute mile until someone like Roger Bannister comes along. Once upon a time, the world was widely believed to be flat, and those experts of the day said that if you sailed too far, you would fall off the edge and sea monsters would devour you. Until Columbus and Magellan set sail and survived to tell the world of their tales. Once upon a time, flight for humans was deemed impossible by the experts of the day, until the Wright brothers flew at Kitty Hawk. And then, a mere 66 years later, after that perceived barrier was pulled down, we know that Neil Armstrong, Buzz Aldrin, and Michael Collins flew to the moon. Age reversal has already been proven to be possible. The idea of age reversal in the laboratories, the work that Aubrey de Grey is doing, the work that so many people are doing, Greg is doing. You know, we have great professionals here with us, the researchers here with us now, and I'm honored to be here with you today. So I would just like to say that, you know, over the years, there have been many people who have tried to find the fountain of youth. They've looked for water, holy water. They've ingested mercury, they've drank mercury, and of course that killed them. And so they did all these things that they thought could keep them to be able to live forever. And now, though, for the first time scientifically, we have this opportunity. As you know, Aubrey de Grey coined the term longevity escape velocity. I think you're all aware of this term, and my wish for all of you is to be able to find a way to reach longevity escape velocity, to live long enough to take advantage of the technologies and the advancements in medical sciences to be able to live an unlimited lifespan. So I wish for you all of that. And as you know, I am, or some of you know, I am the officiator at the Church of Perpetual Life. The Church of Perpetual Life is not a Christian church. It is not a Bible-based church, but a science-based church. We have Nikolai Fedorov as one of our prophets, Arthur C. Clarke as one of our prophets, and we give monthly presentations on age reversal. Johnny was there last night when we had Zach Varkaris giving his talk, and many of you may have been at the live stream. But I'd just like to invite you to attend with us and to surround yourself with people who believe as you do, who believe as I do, that age reversal is possible and that we have the opportunity now to live an unlimited lifespan. And if you can surround yourself with positive-minded people who believe this as well, then I think you'll find you'll have less people throwing mud at you and trying to bring you down. Hold your head high and stay in a good place. And that's my presentation for you all today, Walter. And ladies and gentlemen.
Neil, I can't thank you enough for saying that. You know, we have visionaries in this group who are largely the thought leaders of our time in longevity. But you've done a great job of communicating the passion and the focus and the desire to make a difference. And it does help. And it's, you know, you see secondary and tertiary effects rippling out from all of this. I see it every day. Even in the few years I've been involved, the number of people passionately involved has changed greatly. It's much greater now than it was. Thank you.
That's true.
Neil,
thank you, Stephen. Chris.
Neil, yeah, great talk. Couple comments come to mind, and this is just thinking off the top of my head, inspired by your comments. So yeah, I know several people who are not interested in living forever because they don't believe that they'll be healthy, and that's unfortunate. And I think those kind of people are people who lack great curiosity, will be not as interested. But the people who are, and I think in the athletic side, those sports and activities which people could continue to improve, like right now, they're kind of limited. Once they get to 35 or 40 in a lot of these, they're kind of limited from competing with the earlier 20-year-olds. But I think if we can stop, aging around 30 or 35, I think some of those sports will continue to break records like you talked about. On the knowledge or intellectual side, I think people will continue to develop very deep and broad knowledge over long lifetimes. And once again, the wisdom of the greatly aged will come to the forefront in some aspects because they won't also be suffering from old age effects. And so I think these are two aspects that are going to change societies. And that's my comment. Thank you.
Thank you. You're right, Chris. You're right. Are there any other questions?
Well, I just wanted to say that it's realistic to think that, not everybody understands longevity escape velocity. It's somewhat intuitive, but just to make sure, it's the notion that you preserve or even reverse your current state of decrepitude and then survive to the next breakthrough until you're actually gaining more lifespan than you are losing, or something like that. Probably Aubrey could better describe it, since I think it was his term to begin with.
That's right, Walter.
You said it fine, Walter.
Neil, I want to just support what you said about wisdom increasing with age. One of the things that appalls me the most is the complete ignorance of the current generation to history. I think we need people with some seasoning to stick around a lot longer so we can have a more stable understanding of reality out there, just in general.
Yes.
So I think this is a great greatly
Yes.
overlooked factor and very, very important.
Just to follow up on that, aging is not the only thing that can kill us. We are in a world that's undergoing a polycrisis now. I mean, there are multiple wars going on, any one of which could turn into a global devastation. Nuclear powers are involved in two of these wars, but we're also undermining the ecosystem that supports all life on Earth in ways that could blow up on us more suddenly than we imagine that it's all going to happen gradually, but it could be that there are sudden repercussions and the supply chains could fall apart. There are many ways that collectively we could die, and perhaps once we have more longevity and more stake in the future, we'll be more motivated to solve those problems.
Josh, I think I find people who want to live an unlimited lifespan, who want to live hundreds of years in health, and these are the same people that want the Earth to be in a good condition. I think that those of us who are transhumanists and want to do this, we want the world to be in a great shape and clean, and to have clean air and clean water. And I think that we just need to survive long enough to be able to make all of this happen, and we will.
Yeah, I would agree. I think people who, if you know you're going to be around a long time, you're probably prone to take care of what's going to be there and not push it off to the next generation.
Yes.
You're also more prone to be nice to people because you're going to have to live with them for a very long time.
Yeah, touche.
I've literally, sorry if I couldn't find the hand gesture, but I've had some clients say to me, I'm only around 20 years. I don't care what happens to the planet. Yeah, so we have to stop thinking of our planet as an Airbnb, right? More of a long-term purchase. And that's totally true. And people don't get that. And just, having spent really a lot more time in this industry, and, Aubrey, Greg, even the investors, to me, don't seem like they get it. They're still playing, the money as a primary importance. And I get we need to have money to be able to do what we want to do, but dang, if we can achieve this, it changes everything. And
Yes.
somehow that just doesn't seem to make it into the minds of a lot of people. There's a small group here that, we have to believe it to make it happen. And I don't know what it takes. Some basic proof of concept to begin with. Where's the light bulb that can wake people up to this? Because there's certainly plenty of people with the funds to make this happen or help make this happen. But we need the team to do it.
Just to make sure everybody understands, it's kind of queer how Zoom does this, but there's a button on the bottom of your screen that says reactions, and right next to it is a caret. Well, the caret doesn't work. You have to hit the reactions button in order to raise or lower your hand. Okay?
Thought you were talking about a real carrot for a second. Wasn't sure. But I just wanted to, Rick, what an incredible, analysis for sure. I think the past 4 or 5 years have been a real exercise in trying to understand psychology and putting my brain into the brains of people who are crazy. And it doesn't work because the problems where the planet is facing is based on a neural net that was evolved in a jungle, built for short-term thinking, built for just survival, day to day. So it shouldn't be a surprise when you see swarm behavior of groups of people who basically the blueprint for their brain is got instincts that are all, oriented towards that. Once we understand that the likelihood, and even we look within ourselves as what our first reactions are to certain events or stimuli, once we realize that, we can actually have a chance to change those things. But I think I have particularly given up trying to reach those people who are based on short-term thinking, who live on this sort of limbic system, monkey brain. I call it the monkey brain syndrome. It's too many, because most of the problems that we see today, we can see in the zoo with a bunch of monkeys throwing poop at each other. It just doesn't make any sense at all. I can't understand it. Just like you said, it's not understandable because it's not coming from a place of logic. It's coming from a place of primitive responses. And once we realize, and that's what Facebook is manipulating, that's what media manipulates. So I think society is maturing faster, and I think average with the average we get the emergent behavior of any group is basically the lowest common denominator. So if we can raise that average intelligence of people, education is the only thing that can actually change anything, is putting information into the brains of people who are willing to hear it and able to take action once they do. So a lot of the work that's being done trying to develop this industry, just getting money in, is great. But what happens to the money, and is it actually going to benefit the long-term view? And it's monkey brain. Basically, the answer to any of these problems is monkey brain. And once you realize that, then we can construct systems that either leverage the monkey brain the way it should be leveraged, or because we can leverage greed, the profit motive, and all of that, but we have to know how to do it. And thank you for letting me rant a little bit. That was.
In that case, Kevin, why are you preventing the appropriate spending of 15 million of my donors' dollars?
I have
Hey,
no
Aubrey,
I
could we
have
come?
no comment about that here, Aubrey. Thank
Could we
you.
come back to that later? We'd like to stay on schedule if possible and introduce Mr. Albert Donay, a toxicologist who is going to talk about some thoughts to keep in mind on all this.
Thank you. Can you hear me and see my screen?
Yes.
Great. Well, I apologize for being the person who has to put some negative comments on the table, but I appreciate the opportunity to do this. I come from a background in toxicology and before that, environmental health engineering, and I have only been researching aging issues since the fall when Chris invited me to join this group. Here are my concerns about the types of let's call them therapies I've been focused on, and it's not just blood donations and plasma exchange, but also dialysis and ECMO that I'm concerned about. ECMO is extracorporeal membrane oxygenation, which was used quite a bit more than had been in the past during the COVID pandemic. And everyone knows what dialysis is. So what do all of these have in common? They all cause your carbon monoxide level to go up or down, depending on whether you're the donor or the recipient. None of these procedures mention this in their informed consent, and only ECMO researchers that I'm aware of are currently studying this problem, and they've not found a solution for it. These all cause our body to make more of a substance called hemoxygenase 1. It's the universal stress enzyme. It breaks down heme proteins. One of the byproducts of this breakdown is carbon monoxide. The others are biliverdin that goes to bilirubin, and toxic ferrous iron that goes to ferritin if all goes well, and hot water, which are all contributing to inflammation when they're overactive. And I should mention here, even saline alone will boost CO by this pathway, and it's only helpful to people who have too little CO. If you already have accumulated too much in your life, adding more is going to increase your morbidity and mortality risks, including your risks of heart attack, stroke, Alzheimer's, and Parkinson's. I didn't have time to put it on this slide, but there are biomarkers of CO poisoning that correlate with biomarkers of aging, such as your red blood cell distribution width. The safest anti-aging procedures, I believe, are those that remove fluids without replacing them. A blood donation, phlebotomy, or wet cupping also called cupping with needles, an ancient practice from Muslim and Chinese traditions, but that's illegal in some states in the US, including in California, unfortunately. All of these remove the blood, of course, without adding anything back, and that removes both carbon monoxide bound to hemoglobin, about 99% of it, and the approximately 1% that's normally free in plasma, and which, if your blood or plasma exchange setup is gas tight, is going to be transferred from the donor to the recipient. And very little CO or oxygen, for that matter, can be dissolved in plasma, only 1 or 2%. So most of it is free gas. And when it's returned to the recipient or given to the recipient, it will quickly bind to their heme proteins, both in blood and beyond in tissues. So recommendations for therapy providers: I beg you to start telling your customers about CO effects when you get their informed consent. If some CO change is expected, you should know if it's desired or an unwanted side effect. It can be beneficial, as I mentioned before, for people who are low in CO. How high or low may CO levels go with this therapy, and for how long? I think that's something the patients, or rather the customers, should be informed about. And what should customers do if they develop CO signs or symptoms? In most informed consent procedures, the clinician not only warns the patient what they may expect, but also commits to doing certain things to help them if they do experience any side effects. What about for the biohackers? What can they do while we're waiting for the therapy providers to pick up their piece? The biohackers can do much of this on their own. They can monitor their carbon monoxide stress hour to hour and see how it changes from any treatment, diet, or lifestyle changes they make. They really just need to measure their exhaled CO before, during, and approximately every 30 minutes after until they come back to baseline. It may take an hour, 2, or even 3 hours for the CO effect to appear, and several hours more for it to peak, and then several hours more for it after that to come down again. Or you may see a response come and go within half an hour. If you don't have a breath carbon monoxide analyzer, sorry I didn't have time to put photos on here. They fit in the palm of your hand, about the size of a beeper. You can measure your body temperature. It's boosted by and normally cycles with your carbon monoxide level. It's typically lowest on waking and highest in the afternoon. If your cycle looks anything different than that, there's some abnormal reason for it. That's the end of what I want to put on the table, and I welcome any questions or comments. I know I threw a lot at you, and here's a link to get the slides.
All right, Josh, go ahead.
First, I wanted to ask, how many, just unmute yourself and say yes if you've given blood in the last year. Yes.
Yes.
Yes. Yes.
Yeah, so there's a
No.
handful of us anyway.
Yes.
You're on mute, Josh.
I'm sorry, thank you. I couldn't hear.
I'm sorry. So I wanted to ask Albert a question about the chemistry of CO. I'm ignorant about the basics. I thought CO in the blood is tightly bound to hemoglobin, that's the nature of CO, that's why it's toxic. And this idea that there's free CO and there's CO in the breath, it's all new to me. And where could I learn more about it?
We'll be able to put in the chat a link to a 1-hour webinar I gave last fall to the National Association of Environmental Medicine. And I urge people to start with that. It takes you to a link where you can either watch the whole webinar or just download the slide deck. There's also a 1-page clinical summary I did for them. But the bottom line for all of you who probably have heard of nitric oxide as a critical gasotransmitter that we all make, I urge you to think of carbon monoxide as the evil twin of nitric oxide. Well, they're both evil, but they have their good sides and their bad sides. We'd be dead without them. I guess a Jekyll and Hyde analogy is better.
Yeah, it's hormetic.
It's hormetic. Thank you for the word, Chris. The magic word is hormetic. It means that both too much and too little are harmful, like any vitamin or essential mineral. And there's a sweet spot in the middle, varies person to person and by race and gender and age, where CO is actually beneficial and can, in many studies, actually reverse some of the worst aspects of aging. But again, too much or too little is harmful. And I encourage people to start measuring it so that they can learn what's their sweet spot and how it correlates with their temperature. Chris has done some of this and has learned that every 1 degree Fahrenheit your temperature goes up, your breath carbon monoxide goes up about 4 parts per million from its normal level of 1 or 2 parts per million. So that gives you the ballpark. People who are really sick are exhaling 20 to 40 parts per million, so 10, 20 times normal.
Let's go. John, you had a question or comment? John Berber? Unmute yourself.
Yes, I do. This is the first I've heard of any of this, and I wonder if I look in a physiology textbook or a medical textbook, would I find any reference to this? Or are you the sole person on this planet who knows about this?
I'm not. I've been studying this for 25 years. I've created over 2,000 collections of references on PubMed on various carbon monoxide related topics. And for anybody who wants to follow up with me, and at the end of that other presentation I mentioned, there are links to references. But all of this information about endogenous CO is very well studied, approximately 1,500 papers a year, compared to only 200 a year on inhaled CO poisoning that old school we're all familiar with. But it's a very different field where there are not yet many people interested in anti-aging, but there is a lot of work on diseases of aging because carbon monoxide is such an important cause of cardiovascular disease, stroke, and Alzheimer's.
Would I find this in a physiology textbook?
I haven't read physiology textbooks since Guyton when I was in grad school. I only read journals. I don't know, but certainly in journals.
Thank you.
All right. Albert, if you can stop sharing your screen and perhaps we'll move on to Dr. Kiprov.
Well, I would like to very quickly mention now, so from what Albert said, I guess I can assume that if I have a plasma infusion or a albumin saline infusion, that does not add carbon monoxide. Is that correct?
I can't predict. It depends on where that where the plasma came from. If it's saline, I can predict. I mentioned even pure saline will boost the heme oxygenase carbon monoxide pathway. It didn't deliver carbon monoxide, but as soon as your body detected its presence at a higher concentration than the moment before, it starts to make more carbon monoxide in response.
Okay. Shall we continue? Dr. Kiprov, you have the floor.
Yes. So I can share the screen. Yeah, I guess.
Yes, please.
I'm going to show you a few slides from our latest research story here. So in the last 2 years, we did a clinical study that was placebo-controlled in.
Sorry, sir, I don't think we're seeing your charts.
You are screen sharing. You don't see it in my screen?
We see a screen, but we don't see charts.
No, no,
We see your presentation list. The presenter's view, I think you need to switch your monitors. You have two monitors that must be screwed.
you did the slide change now?
No, sir.
No, it says good morning, Las Vegas, Cleve Clinic.
Oh, no, okay. Uh,
We're seeing the open file menu. Oh, there you
yeah,
go.
There we go.
it's okay.
Cancel.
Okay, you see it now?
Yes, sir.
Yes.
Okay, very good. All right. So we work very closely with the Buck Institute for Aging in close by here, as you know. And they declared recently that data-driven health is going to be the biggest revolution in the history of medicine. I fully agree, and I added to that it has to come, that this data has to come from human-controlled clinical trials. A lot of stuff in aging has evolved from medical models, and they don't apply to humans at all. It is very difficult to translate, excuse me, an animal model to. So I don't have the time to take you through the parabiosis experiments that Irina and Michael Comboy and the Stanford staff did in 2005 and published, but they approached me and said, can we do that in humans? And I worked on that for a while, and I published a hypothesis that plasma exchange may be the parabiosis model for humans. So I'm going to show you what therapeutic plasma exchange looks like for those of you who don't know.
Therapeutic plasma exchange, or TPE, refers to a specialized medical procedure in which blood separation technology is used to remove abnormal plasma constituents. Whole blood is removed from the patient into a blood cell separator, which utilizes centrifugal forces to separate whole blood into its individual components: plasma, platelets, white blood cells, and red blood cells. Plasma can be removed and replaced with physiologic fluids to treat relatively uncommon but usually life-threatening diseases.
So this is how our clinic looks like at the moment. There are people that come here, they're stressed out because they see a machine and blood and all that. So we have a little dog to calm them down. So my idea was to utilize therapeutic plasma exchange to remove the plasma of an older person, presumably containing a lot of gyronic substances, and replace it with some fluid. Obviously, the natural answer to what to replace it for would be plasma from young people. So I have been working with plasma and plasmapheresis with fresh frozen plasma for the last 35 years. And I was very much opposed from day one to this approach. The reason for that is that each time you use fresh frozen plasma, inevitably, you're going to see side effects. And if we use other fluids, the side effects are minimal, less than 3%. The moment you start using FFP, the side effects skyrocket. And the idea to create side effects in relatively healthy individuals, many of you, many of us, many people that come here are, older people that want to live longer, but they don't necessarily have a particular disease that requires aggressive intervention. So I was looking for something else that will be more benign. And we came up with something that we use in therapeutic plasma exchange on a regular basis, which is 5% albumin. So 5% albumin is made of plasma. Plasma is collected in plasma collection centers throughout the world, and is usually collected from younger people. The average age is less than 25. And the reason for that is that if you go to a conventional blood bank to give blood, they're not allowed to pay you. You can have juice and cookies, but they don't give you money. In the plasma centers, they pay for every pint that you donate. And therefore, younger people, usually college students, go there and their plasma is collected. So the albumin is actually collected from young plasma. In addition to that, albumin is a powerful antioxidant. It has anti-inflammatory and immunomodulatory. And albumin is the major part of the plasma. Most of it is albumin. What is removed from the plasma is coagulation factors and immunoglobulins. It is highly unlikely that coagulation factors are the infusion of health. So I think that albumin most probably has what we need in terms of rejuvenation when we remove the old plasma. So with the convoys, I did preliminary studies with small number of patients that was uncontrolled, and this is well published in very prominent journals, and we saw some very encouraging results. However, until we did a controlled clinical trial, we couldn't brag about it. And we designed a controlled clinical trial that had 4 different groups. I'm not going to take you into these. One of these groups was a sham pheresis, where the patients were simulated to have plasma exchange, but they did not. So I'm going to show you some of our results for the matter of time here. And this is the Horvath clock done in the Horvath lab, and this is Grim age. As you can see here, this is the treatment groups. With every treatment, they get younger. You can see here. This is the sham pheresis group, the placebo group, chronologically aging as you'd expect. You age with every day. So they aged over the 3 or 6 months we did the treatments. And this is true for a different methodology, different algorithm they measure. And we did that with different laboratories as well. This is from True Age, the same DNA methylation test. As you can see here, the patients who did the treatment got so we did that pretty much with all clocks available today, including glycan age. We also followed clinical parameters. As you know, sarcopenia, or muscle weakness and loss of muscle mass, is a indication and a very bad consequence of aging. As you can see here, the hand grip, that's how we measure sarcopenia and strength. It increases with every treatment until it reaches maximum strength after the 6th treatment. The same is true for balance, and this is a up and go. We measure the speed of walking of the people. As you can say, the seconds they walk a certain distance is less and less as the treatment continues. We use artificial intelligence to measure overall health and dramatically increase here. Include the same test that measures emotional health as well. And I will show you what some of the patients say about the treatment.
I felt incredible after the procedure. I felt I had more energy, woke up feeling less achy. Just overall felt really good. A big difference.
I feel great. I feel more energy. I've put on muscle mass. I also just have a drive, absolute drive. And I just feel very, very happy. And I also have a wonderful sex drive. And I'm 75. I've wrapped up my 6th treatment here at the clinic. And I tell you, my life has kind of changed after I started here. I think it's after my 4th treatment, I felt such stamina and my God, my strength level I can open jars now where I couldn't before. You know, when you get older, it's really hard to open. I'd have to ask my husband, but now I can open my jar and open my vitamin pills. If I had a big day where I had to be very active, I would be shuffling myself to the bed and I'd have to take a pain pill at night, but I haven't had anything for 3 months now. I haven't needed it. My pain is gone, actually. I had pain in my hand, my legs, and I don't know how to thank you.
So that's our story. I'll stop here. So if you have any questions.
Yeah, Dr. Kiprov, can I ask if anybody is doing now like repeated trials for like years on end to see how much improvement, you know, if somebody, we think this, we're gonna have to continue this type of treatment. It's not a one-time thing. And I know your protocol had several, like 6 series of treatments. Is anybody looking yet at like, if you keep going year after year, where we can get to?
Well, we're not there yet. Obviously, we just finished the trial. Actually, some patients are still going on. So the trial is not over. We are following everybody who who wants to be followed, and we hope to have the answer soon. We recommend after the initial 6 treatments, 1 to 3 treatments per year as a follow-up, because as you'd expect, the effect of the treatment wanes over time. One thing we did discover is that there is no room for generalization. We are not going to say everybody needs that many treatments per year afterwards. Everybody's different. And we measure, 6,000 different parameters to figure out who needs and how much. So it's not going to be an easy answer to your question, but we hope to have some answers, at the end of next year, hopefully.
Okay, Walter?
Hello. I was actually one of Dr. Kiprov's patients a year and a half ago, and it worked out well for me. But I there's a lot of things I don't really understand. One of which is that, so you take out the natives, the endogenous saline, and you replace it with basically salt water and albumin, purified albumin, if I'm not mistaken. So a whole bunch of factors have been removed, countless proteins and peptides and all kinds of stuff. And I guess your body replaces all of those things. But does it replace them in the old body mode, or does it? I don't know. Could you elaborate on that aspect? So how exactly is it rejuvenating the patients?
There are some things that we do know, and there are some things that we don't know. So what we do know is that albumin has multiple receptors on its molecules, and these receptors attract bad molecules, things that affect the body, pro-oxidants and so forth. So over time, especially when we age, there are many molecules that accumulate in the body. Think of it as the oil in your engine of the car. It gets older, you have to replace it. And albumin is the major antioxidant in the body. These receptors get saturated with progeneric and pro-inflammatory molecules. And when we remove it, we remove the old albumin and all these molecules, and we give you new albumin with fresh receptors to rejuvenate the whole system. So it's a matter of homeostasis. You provide a new environment, a new milieu for stem cells and other cells in the body to grow. Yes, we do remove a variety of other proteins. Some of them we do replace artificially after the procedure, such as immunoglobulins. The others appear to rejuvenate themselves or regrow very fast. For example, fibrinogen gets back to completely normal. So one thing that's very interesting, and we don't talk much about it, but we should, is that what we discovered is that plasmapheresis does not only remove certain substances, but encourages certain substances to get up, to grow. So we see certain hormones, for example, hematopoietic hormones, to get elevated after the procedure rather than being removed. So this is an interesting observation that requires more studies, but we're still evaluating the data. We're still discovering incredible things.
All right. If I may, we should move on, keep on schedule. Dr. Middledorf.
Hi. I'm honored and delighted to be here. I'm going to give a brief history of my thinking and of the field of plasma therapies. And then I'm going to give an ad for the work of Harold Katcher. I was just on the phone with him a couple of hours ago, and I think it's the most exciting thing that's going on, not only in the field of plasma therapies, but in aging in general. So I've been in this field for 28 years this month, prompted by realizing that aging is not something that happens cell by cell. It's not molecules accumulating or the cells wearing out, but it's centrally controlled. And we still don't know where the central control is, but we learned something about how the information about the body's age is communicated to the body, starting with the convoys. Here is doctoral students in Tom Rando's lab published a seminal paper in 2006, which really got us going, that you sew an old mouse and a young mouse together, and the information about age seems to be transmitted in both directions. The old mouse shows signs of getting younger, and the young mouse shows signs of getting older. So there's something in the blood that's communicating information about the age of the body, and the body is responding to that. Thanks also to the work of the convoys, we know that that's not in the cells. It's not in red blood cells or white blood cells. So it's something in the plasma. Moving now to Harold Katcher's work, he took an educated guess about what that was, and he had an idea for experiments starting about 6 or 7 years ago. He got a small grant from Akshay Sanghavi, Indian entrepreneur who was interested in this. He went to Mumbai and did experiments where it's unregulated and where it's much cheaper, and turned old rats into young rats using what he called a plasma distillate. What was the word? Plasma fraction. He talked about it as a plasma fraction, and he named it E5. And we didn't know what it was until last summer. Akshay, his partner, sent me a paper that came out of the Schmidt institute, a hospital in Los Angeles, where doctors there were reporting dramatic rejuvenation results from exosomes. They transplanted exosomes from young animals into old animals. They had preliminary experiments in human culture cells. They were all excited about exosomes. And I asked Akshay, so how come you're sending me this? Is this part of E5? And he wrote back, E5 is exosomes, he said. And at that point, I put it in my blog, but other people knew in other ways. The cat is out of the bag. We now know the secret ingredient, the secret sauce that enabled Harold to get the dramatic results that he got. And just to reiterate, using many measures of physiological health, the rats were much younger than, he started with 2-year-old rats. They were much younger physiologically. They did better in maze tests, experiments on learning. There was a Horvath clock designed to measure both rodents and humans, and their age went down by more than half in this experiment. And there was one lifespan study which had puzzling results, puzzling in a lot of ways. The control rats lived much longer than we'd expect the control rats to live. The test rats all lived longer than the control rats, but only marginally, except for one rat, which doubled its lifespan. So there seems to be a lot of work to be done to even begin to understand that. But I maintain that Catcher's technology for separating exosomes from young animals and giving them to old animals may be the most promising rejuvenation technology available today. And I'm here as a carnival barker. I want everybody to be, I want labs around the world to be replicating this result, taking it further. There are lots of unanswered questions that remain. As I talked to Harold a couple of hours ago, he's already working with Greg Fay, who's here, and they have some money, but they want to form a consortium. So one of the models that's come into the field in the last 10 years or so, there's a lot of venture capital money that comes in. So can we come up with intellectual property? Can we have a patented molecule? And that's not going to be this. It's not patentable. Whether there's intellectual property to be had is questionable. And the fact that we may have that the most promising anti-aging intervention that we got may not be profitable, or we have to find creative ways to make it profitable. This is a big challenge for all of us, but I'm hoping we rise to that challenge, find ways to fund the research that's most promising, rather than find ways to put science behind the business plans that we have in mind a priori. So what are the things that remain to be done? Well, a really big one is that Harold used pig blood to rejuvenate rats, crossing species barriers. And it's absolutely essential that we're able to do this, because nobody wants to be in the business of raising babies to be slaughtered. And an international market for human blood is just a nightmare. So the fact that there are already hundreds of millions of pigs slaughtered at the age of 6 months around the world is very promising. But we have 1.5 results for that. One, yes, it seems to work in mice, in rats rather, and the half is that Harold one day a year ago painted some of his exosome extract onto one hand and not the other, And every time you talk to him, he'll gleefully show you the two hands. Where the skin in his treated hand looks much younger than the skin in the old treated hand, the untreated hand. So I'd say we have some indication that we can cross species barriers, but certainly one of the prime things that needs to be done is to try exosomes in humans. Do we need to remove old exosomes? Would it help to remove old exosomes while we add young exosomes? Is another big question. Are there different kinds of exosomes? Again, talking to Harold, he says that his procedure already separates different kinds of exosomes, and he suspects that there are some, I don't understand the difference, extracellular vesicles that are not technically exosomes, but they're also produced in the same way. They're also little packets of RNA, DNA, proteins, who knows what else, encased in lipid nanoparticles that are sent out by all the cells in our body. I don't know the difference between exosomes and extracellular vesicles, but other people do, and they've categorized the different types. A lot of work remains to be done in separating these and seeing where is the most active ingredient. Harold hinted that it may be that there are loose RNAs that are not in these vesicles that are also part of the benefit that's derived from this plasma fraction.
All right.
The usual stuff about dosage and timing is work that remains to be done. And I take it as a huge blessing that Harold is not interested in keeping this a secret and making $1 billion for himself, but is willing to share the technology and form a consortium to spread this research around the world and to do it in parallel so we get it done as fast as possible. One more thing is that Harold has volunteered as patient number 1, and he said there is not yet enough exosome accumulated, refined from pig's blood to do 1 human, but that he would be eager to be patient number 1. And just what a difference would that make if we had an example of one person who's really dramatically rejuvenated, so that we can see it in the videos, that it's not just a testimony, but he looks like a 30-year-old instead of an 80-year-old. What a difference would that make to our movement? Thank you for listening, and I'm open to questions.
I think we should hold questions and try to stay on schedule and turn it over the floor to Dr. Stickler.
I'm Dr. Stickler. I'm located in Austin, Texas, and I'm a clinician. I do some research, clinical research with some private companies, but I am not a university-based researcher. In fact, I was a general and vascular surgeon, left that to do age rejuvenation back in 2005, thanks to a talk from Aubrey de Grey. And Josh and I have had conversations over the years. We were both in that camp of the programmed aspect of aging when nobody else was. So it was great to see this come along. Now down here, we use, we're part of a couple studies, but we're using young plasma. And we're one of about 5 centers, I think, here in Texas that are able to access the young plasma for infusion. And we generally give 1 to 2, sometimes 3 liters in the course of a month. We do that. I don't like to do just infusions of the young plasma. We always do apheresis first with the first unit. And when they come 3 to 6 months later, we'll do the same thing. But we've infused just over 100 liters of young plasma now. And we don't have all the data put together because multiple centers are involved and our data is more anecdotal at this stage. But we get the true diagnostics tests on that. Most of my patients have had the coronary CT with the Clearly exam And we're getting ready to start a study with a company called Caristo out of London that takes those coronary CT exams and looks at inflammation. Inflammation to me is the key, decreasing the inflammation of the brain, decreasing the inflammation of the heart and the other organs. This is the target that I'm looking for. And I do feel like the apheresis alone, the removal of the plasma, replacing it with saline and albumin, I think it's great. I did a study on myself first 6 months of last year, did 3 exchanges, roughly looking at all aging categories. It reverse aged me about 4 years if you take the True Diagnostics test. The young plasma, we're seeing most people respond even greater than that. And it just makes sense from the research with removing the progesteronic cytokines and then putting in the young kind of youthening cytokines. And we're seeing that. I mean, just removing doesn't give people the response that they get from like the vasculature. I mean, we know that young plasma will change the transcriptome of the vascular endothelium, both in the brain and elsewhere. And so that's required. I mean, we can't just remove these. I feel like we need to also put in the structure and function that's required to have these things work. And we've been seeing great responses from it, changes in blood markers, just in cholesterol, inflammatory markers. And we usually don't test until they're 6 months out from their procedure. So it's not like we're doing it and immediately testing these markers. This is 6 months out, and people that we couldn't get their cholesterol into a really nice profile for a couple of years, they get this and they've done great. I mean, you think about it, and when we're talking about just what is in the young plasma, I mean, 1 milliliter, 1 cc of young plasma has approximately 1.86 billion exosomes. And we're infusing a liter, which will transfer to about 3.74 trillion exosomes. I mean, that's outrageous. There's 10,500 plus individual proteins, 5,000 different peptides, 45 cytokines, 50 different sex-specific hormones, enzymes, and minerals. It just really makes sense to me that this would work. And complication-wise, there's been a lot of controversy about this, and I'm not quite understanding where the controversy comes from, because I mean, you talk about deaths from multi blood product infusions of plasma. You look at the CDC numbers, and there was 1 death in 2019 in millions of multi-transfusion patients. 2020 and 2021, there were 0. When you look at some of these statistics, though, they're really kind of sensationalized, I think, because a lot of people count like a rash or itching as a complication. We always give Benadryl to our patients beforehand, and we haven't had the issue with it. But this is one of the areas that I'm excited about. The young plasma, the apheresis. We're involved with a company where we're doing polystatin gene therapy injections with plasmids that don't incorporate into the DNA, and they have a kill switch with them. I'm getting ready to be patient 0 for a clotho plasmid. I did the polystatin last July, gained 6 pounds of muscle, lost 10 pounds of fat in 6 months, and really didn't change anything. And I've injected, not here in the States, but I've injected around 16 of my clients with the polystatin, getting great responses. I mean, the levels are going from, my level was 6 initially, and I'm now 24, which is an ideal youthful number on the follistatin. But yeah, I mean, we do a lot of the testing. We work with people that have made educated decisions to do things that aren't necessarily mainstream, that aren't legal in the US, in fact, sometimes. But as Dr. Cohen was talking about, the Prospera clinic down in Roatan, I was just down there. I was down there when you were down there, Aubrey. But it's a wonderful area to go to for rejuvenation therapies, and you know, having a clinic down there is going to be ideal for us.
Questions, comments?
If I may. So this, you know, not just Dr. Stickler, but Josh and others, is wait a doggone minute. This age reversal thing, how far back is it going to go? It sounds a little unlikely that I'm ever going to be, I don't know, sucking my mother's breast again. What, you know, is it? What are we just going to go back to 35? And how does it magically stop at that age? There's, you know, this is something I have opinions on, but I think that there's a lot of the people here haven't really thought it through.
Well, there's this suggestion that the M of the OSKM factors is the one that keeps the youthening going. But if you're just using the OSK, I think it was Sinclair that said taking out the M, the OSK will naturally stop at a youthful level. I don't think that's been proven yet, but that's the theory on it. I'm excited about that because a lot of the small molecule treatments using OSK are showing huge promise with rejuvenation, and some of the using the messenger RNA to reprogram like the skin cells. They're talking about a 30-year skin structure and function reversal in the research right now. So there's a lot of stuff out there that's really exciting about true age reversal. This is an area that I'm really focused on.
All right, thank you. Albert?
Thank you. That was great. I have questions about 4 biomarkers. I'm curious if you've followed their progress in yourself or your patients. They are ferritin, bilirubin, the red blood cell distribution width, and testosterone.
Mm-hmm. Most of my clients are on testosterone, so I can't really say what is happening with that. I do see RDW going down, which, you know, that's probably, I think, the number 3 biomarker right now for aging. So that's working really well. Ferritin typically settles in somewhere between the 60 and 140 range. When people are high, it tends to come down after the young plasma therapies and after the plasmapheresis with the saline albumin.
Do you have bilirubin?
I don't measure bilirubin. It's not part of our assay.
Well, that's
If I
great.
may
Thank you.
follow up, Albert. Working with Albert, I have plotted my RDW over the last several years, and it came down from above 15 to now down below 12, but I don't yet know what was the particular thing or set of things that contributed, but I'm hot on the trail.
You know, there's a strange thing because the True Diagnostics in the new omic age, they're looking at methylation aspects that create the RDW. And they're high in almost everybody that I'm testing, even the ones that have low RDWs on the blood tests. So we're working with them, right? I'm on their scientific advisory board. We're working with them to try to figure out why we're seeing such high impact of aging from they're showing that it's increasing aging in their algorithm when this methylation is significant there, but it's not correlating to the RDW on the clinical testing.
All right. May I suggest we move on to our next speaker, which is Steve Buss.
Hello there. And let me pull up my presentation here. Can you hear me okay?
Yes.
Great. All right, so I can't see participants for the chat. I've only got one monitor today, Chris, so if I need to change anything, let me know. So Josh, I put up, after you asked about blood donations, I had to add my a photo, an image from my Red Cross blood app. I'm one donation away from my 6-gallon badge, and I'm on track for my 7-gallon badge later this year. So 2023
I'm sorry, Steve, do you have charts?
I do. Oh,
okay.
I'm not sharing my screen, am I?
Not yet, no.
That would always, I think that would always be good if I shared, wouldn't it? I thought I did. How about now? Yeah?
Yes, thank you.
Great. Okay. All right. So now Josh can see that I've just about hit my 6-gallon badge. I love donating at the Red Cross. It's great. So my name is Steve Beck-Buss. I'm a professional database app engineer and an independent part-time longevity science researcher. I've been a biohacker a long time. It's a pleasure and an honor to be in the company of people I have followed for 2 decades now. Dr. Conboy, I guess, just left, but actually I'm going to mention their study in the presentation. Dr. DeGray is here. I still remember that debate you participated in, Aubrey, back in the day, and it was at Cambridge or Oxford, someplace. And Josh Middledorf, of course, I follow your blog all the time. And Dr. Kieproff, I am so excited about seeing your new study. I'm a big fan of yours. And of course, you are the author of the initial hypothesis paper about how plasma dilution all by itself could make for a profound difference. Harold Ketcher isn't here, but I remember where I physically was when I first read his 2013 review of the literature, and then his 2015 article as well. 2023, so I have been studying longevity science as my passionate hobby for 25 years, and I have something like 12 to 15,000 hours in. I do most of my reading at night. I can't tell you who's in the World Series or the Super Bowl or make out what model car is driving down any street at any time. And I have a lot of other ignorance, but I have spent a lot of time studying longevity science. And last year, my head got turned around possibilities for rejuvenation. And in this presentation, I'm going to explain how that happened. And this phrase, the day the universe changed, the year the universe changed, comes from James Burke's great documentary series and his book, The Day the Universe Changed. And of course, what he's really talking about is the same kind of thing that Thomas Kuhn spoke about in his book, The Structure of Scientific Revolutions and a Paradigm Shift. So where are we? This was how I saw the literature before I came across the Conboy study of August 2022. This is how I saw the literature. There's 3 streams of literature that had gone on for 20 years documenting interventions that had demonstrably positive impacts on survival probability. Epigenetic reprogramming, diluting aging factors in the blood or adding younging factors to the blood, and also triggering what's called the cholinergic anti-inflammatory pathway. Now, I think most of you are probably familiar with the first 2 and maybe not so much the last one, but this was how I saw it, and this was a confusing thing for me because I am interested in rejuvenation. And the question is, which one is the optimal, which one is the best one? I really had very little sense of how they were related, although I just came across a diagram showing that in 2015, I thought numbers 2 and 3 were there. A way to think about this, just to be clear, there are, cellular membrane, cell membrane and intracellular targets that are important. I'm not saying they're not. But today we're talking about cell surface context interventions like plasmapheresis, TPE, and also this thing called cholinergic anti-inflammatory pathway. So the August 2022, I came across the study in December, so coming to grips with all this really, for me, did take place in 2023. The Convoys published a study, Old Plasma Dilution Reduces Human Biological Age, a clinical study. And I believe this was the first study that I came across that pulled together these 3 20-year-old streams of literature in a way that made sense and I could construct explanations around. Let me go back here. So what we're going to do is I'm going to first talk about diluting aging factors in the blood plasma and epigenetic reprogramming, and then I'll talk about this other relationship. And I will be using the word dilution. I don't have the expertise, and perhaps no one does, to evaluate the relative worth of getting rid of old factors versus adding new factors. And I'm not intending to communicate a position on that issue in this presentation. In that August 2022 study, the Convoys showed that through plasma dilution alone, through TPE, those sessions of TPE they did, they showed that there was a measurably younger systemic proteome that developed. In other words, the epigenome changed merely because of plasma dilution. And of course, partial reprogramming of the epigenome is one of the 3 major explanations of aging. In fact, there was just a literature review published this last week. I forget, it was published in some other country, but saying, partial reprogram, changes in the epigenome really are the cause of aging. So the fact that plasma dilution itself caused some kind of reprogramming of the epigenome, that's a big deal. Now, that Convoy 2022 study isn't the only study that shows that changing factors in the plasma can make a difference in the epigenome. Here's the reference to Harold Ketcher's study that Josh Middledorf spoke about just a minute ago. And here's these diagrams are meant to be illustrative. I'm covering a lot of ground. There's a lot of detail here. I'm moving quickly to get it done. But Harold Ketcher demonstrated that changes in the epigenome took place. Steve Horvath was in on the study. I also wanted to highlight that TNF was also reduced in the blood plasma in the Ketcher experiment. And then I was watching, I love ARDD videos, and I watched Vadim Gladyshev talk about a study he was a part of that showed that plasma, and this, what was the context of this study? I think this was the study they joined some rodents and then they separated them. And what they found was an increase in survival probability. And they also found evidence of changes in the epigenome. So that first relationship of, to my way of thinking, the evidence is mounting that plasma dilution or adding young factors to the plasma does make changes in the epigenome that are associated with the kind of younger profiles that conscious and deliberate attempts to trigger epigenetic change through partial epigenetic reprogramming, they appear to be doing very similar things. And there's not much more I know about that. So now, the cholinergic anti-inflammatory pathway. The CAP is not well known in the longevity science movement literature or among its thought leaders. I think it's among the most important things around. I have spent thousands of hours studying it. Doesn't mean I'm an expert. But what it is a brain to spleen mechanism that inhibits inflammation in the plasma. Also, it increases survival probability when triggered by means that are understood. In other words, there are certain ways to trigger it, certain optimal times to trigger it. And the basic idea is that the blood circulation system flows through the spleen, triggering that mechanism in the brain results in reduced inflammation in the spleen and blood plasma through the interaction of several different kinds of receptors, several different nerves, and several different neurotransmitters. But it's a complex process, but it actually does do this. It's a real thing. And when the CAP is optimally triggered in an informed way, it can profoundly increase survival probability, even when lethal endotoxin is administered. I put up one of many survival probability diagrams that I could put up. Let me just walk this through quickly. 4 groups of rats to control. You perforate the intestine, the rodents die quickly. I think these are mice, actually. You cut the vagus nerve between the brain and the spleen, and then you perforate the intestine, and the mice die faster. And they die faster. If you electrically stimulate the vagus nerve with an electrode and then perforate the intestine, 70–80% of the rodents survive. If you pharmacologically trigger the vagus nerve, which is something equivalent to putting an electrode on it, and then perforate the intestine, about the same number of rodents survive. This kind of survival probability experiment is in fact the evidence that there is this brain to spleen mechanism that reduces inflammation in the blood circulation. Now, this is just one here. Let me go back. This is just one of many different architectural diagrams of what this mechanism looks like. It's rooted in the brain through the vagus nerve. This is a communication junction of nerves, shifts to the splenic nerve, releases noradrenaline, which results in the release of acetylcholine, which inhibits inflammation in splenic macrophages, which traverse through the blood circulation system in a macrophage M2 phenotype, which is a less inflamed phenotype than is the M1 phenotype. That is the key mechanism, brain to spleen. Macrophages get reduced. TNF, the expression of TNF in the spleen is reduced by triggering this pathway. And once these macrophages are in the blood circulation, TNF is also reduced in the blood plasma. And what has been documented in many studies is the fact that these inflammatory cytokines, when they are inhibited through this cholinergic anti-inflammatory pathway, survival probability increases. I recently spoke to someone that you all have heard of who said, Steve, this sounds magical. And I thought, well, yeah, it does, doesn't it? But I'm not making it up. It's in the literature. You can Google it yourself. And in fact, if you do Google it yourself, you will see that the cap is not some obscure alt health fad. It has a literature in plain sight that you can do Google searches on. This image that you see is an image generated. This is the image return from a search for cholinergic anti-inflammatory pathway. There are dozens and dozens and dozens of these images, illustrating various facets of how this all works. The cholinergic anti-inflammatory pathway is the motor arm of a larger reflex called the inflammatory reflex. It's the motor arm, not the sensory arm. The motor arm is the arm of a nerve, of a nervous reflex that would cause you to pull your arm away from a hot stove. That's the motor arm. The cap is the motor arm of the inflammatory reflex. Hundreds of scientists in hundreds of studies have described and explained what the cap is and does, how potent it can be in reducing inflammation in the blood plasma, and how potent it can be in increasing survival probability. So you say, yeah, but what does this have to do with the Convoy study? Well, that was the wild thing. Here's the from the abstract of the Convoy study, summarizing some detailed findings that they document in the body of the study itself. They say in this very short abstract, mechanistically, the circulatory regulators of the JAK-STAT, MAPK, TGF-beta, NF-κB, which NF-κB being, of course, the master regulator of inflammation, and toll-like receptor signaling pathways become more youthfully balanced through normalization of TLR4, toll-like receptor 4. Now, of course, they don't use the word inflammation here, but they do in the body of the literature. And the minute I saw that abstract in December of 2022, this new journey of mine began, because I'm a fan of Kevin Tracy. I think he's an amazing scientist. He's also, by the way, the president of the Feinstein Research Institute at Normal Health in New York. He has access to money, I imagine. At any rate, he's the lead scientist who discovered the cholinergic anti-inflammatory pathway. And this graphic figure in the middle of the screen, figure 2 from this study at the top, was one that I thought so important that I sent it off and got a canvas print of it to hang on my bedroom wall. That's how sort of crazy I am. But the thing you'll notice about this graphic figure in the middle is that key elements that the Convoy said in their study were key to this inflammatory nexus within cells that were triggered by aging factors in the plasma. And it turns out that this figure 2 is a picture of, it's an intracellular picture. Here is TLR, toll-like receptor. Here's MAPK, and you'll notice that acetylcholine inhibits MAPK. Acetylcholine also inhibits JAK-STAT from being inflammatory, stops the expression of NF-κB. And there are other kinds of diagrams I could show. The key point I want to make about this goes like this. Kevin Tracy wrote this study, wrote this literature review in 2009. Since then, it has 815 citations. This is a well-known thing in the scientific literature. And it turns out that the key features that he documented in this study and in others that evolution established in us, in mammals who don't have spleen or vagus nerve or splenic nerve disorders, this mechanism and its intracellular targets turn out to be roughly comparable to the same targets that the convoys said were key to aging, such that if you removed aging factors in the plasma, these factors were normalized. What they say here, they become more youthfully balanced. They become less inflammatory. I'm going to go on from that, and I have a couple different presentations about that science in more detail, but let me go on because we need to get done here. The CAP mechanism inhibits these same factors, but it turns out the key to the mechanism isn't really the brain so much. Instead, the key to the beneficial effects of the cholinergic anti-inflammatory pathway are really these macrophage inflammatory cytokines that exist in the spleen. And those splenic macrophages can be made less inflammatory in multiple different ways. For example, we saw earlier that acetylcholine esterase inhibitors can trigger that pathway in the brain. You can also use non-invasive vagus nerve stimulators on the ear, for example. What was that? Transauricular vagus nerve stimulation, I think it's called. You can use a magnet on the nerve, put an electrode on the nerve. You can use ultrasound directly on the spleen. How else? And then nicotinic alpha-7 nicotinic acetylcholine receptors also can be agonized or pinged in the blood circulation. The nicotinic, I think of it as the receptor of life. The alpha-7 nicotinic acetylcholine receptor is the receptor that is pinged by acetylcholine to reduce intracellular expression of NF-κB. Also, I don't have a diagram of this, but it's also true that there are alpha-7 nicotinic acetylcholine receptors on the mitochondrial membrane. And there's been at least one study showing that when that receptor is agonized, it reduces mitochondrial DNA export, which of course reduces inflammasome expression coming out of the mitochondria. So this is a big deal. So what I've shown, what I've tried to summarize is my new understanding of how these three interventions that all three increase survival probability, how they're related to each other. Now we know the evidence, I think, is accumulating. The Convoy study was the first study I found, but Harold Ketcher's study does also. A study by Gladyshev last year also showed that aging factor dilution or younging factors results in epigenetic reprogramming. And what we also know now is that diluting aging factors in the blood plasma impacts the expression of intracellular inflammation that is also a target of an ancient, over 100 million years old, because it exists in rodents. Mother Nature established an ancient, evolutionarily conserved mechanism, brain to spleen, but it can be triggered just through the spleen. And the name of this mechanism in the scientific literature is the cholinergic anti-inflammatory pathway. You can also find it under something called the inflammatory reflex. So I don't know how I'm doing on time. I had some practical thoughts about this.
Yeah, let's try to wrap up if we can.
Okay, I'm happy to take questions.
Surely there are questions and comments after all those great details.
Steve, I there's a lot of material there. I don't completely understand the cap yet, but
Yeah.
if you keep visiting with us on it, maybe we'll understand it even, or maybe I'll be able to understand it. But thank you. Does this have anything to do with the levels of arachidonic acid? I mean, that's a little out of left field, I know, but
I don't know about those details. It probably does, but I don't really know them. I do have one question. Well, that doesn't require any understanding of the cap. The question is, will conscious and deliberate partial epigenetic reprogramming, when it's available for humans, provide value that serious plasma exchange does not? In other words, if you can get your epigenome, get a more youthful epigenome just through plasma dilution or young blood, which clears up the plasma in your blood circulation and also reprograms does a lot of epigenetic reprogramming. Is there any additional benefit from engaging in a deliberate and conscious attempt to do partial epigenetic reprogramming using something like the OSKM question?
Steve, did you see Daria's question in the
Oh no, let me look for it here. I'll look for it.
Yeah. Well, this is Johnny. I'll jump in. I'll just suggest that partial reprogramming would be, if not a one and done, would need to be done less frequently. And it's my belief, based on what I've seen, and I'll be talking about my little project in a moment,
right,
that whether the therapeutic plasma, plasma removal or replacement would need to be ongoing, and that's been my experience as well.
All right.
That's all.
So I don't know if Dr. Kiproff is still in the room. My thinking about how to integrate triggering the cap along with doing plasma-related rejuvenation resets, how would something like that look? What I see is that one would want to have a daily regimen up here of triggering the cap every day, because its anti-inflammatory effects only last about 24 hours. To do a daily regimen every day. But my question is, if you have a great regimen, if you have a great daily regimen, can't the frequency of the need for plasma rejuvenation resets be extended? If you look closely, you can see that in several studies that are looking at the post plasma reset experience, that inflammatory markers go up after a while, including TNF. And it seems to me at some point, one would be able to take a test, get a measure of the inflammatory condition of your blood circulation, and then you could time your next plasma rejuvenation reset when it's needed. So, and Dr. Kiproff said this during his talk today. He said, there's no general rule. Well, of course there's no general rule, because people are following different qualities of personal regimens. Anyway, I will close with that.
All right, thank you, Steve. We're going to have Didier Cornell. I'm probably not pronouncing that right. Speak next. Steve, I guess you can stop sharing your screen now.
Oh yeah, I'll stop. Yeah. Let me find the button here.
Daria asked if the capsaicin real quick.
Yeah, with regard to that question about capsaicin actually triggers heat shock protein release, and heat shock protein is a heat shock protein 70 actually, and heat shock protein is operates intracellularly and in the mitochondria. So I think the answer to that question is no. Instead, it takes place in the mitochondria by triggering heat shock protein.
Okay, let's move on. Didier and Steve, please stop sharing. Wonderful, thank you. Didier,
unmute.
I had to temporarily mute you, Didier. Sorry about that. Please unmute. Walter, perhaps you can unmute him remotely. There we go.
Okay, I'm
Yeah.
sorry. I'm with the computer in, and I have a very short presentation, and also very use of my computer incredibly.
This is coming through very badly, Didier.
Yeah. Okay, I come back in 5 minutes with another computer.
Okay, in the meantime, I suggest we let Griffin, the ad hoc requested speaker, since Dr. Conboy had to drop out.
Hello, can you guys hear me? Am I coming through okay? Or?
Yes.
Hey everyone, happy Friday. I'd really like to thank the organizers here, Walter and Chris. It's a pretty good turnout. I'm impressed. I think I saw 38 people here a little bit ago. Yeah, my name's Griffin. I'll be very quick. I want to know if you all want to hear a little bit about the social side, not the hardcore science, but the social side of life extension. So very recently in the past week, myself and a couple others, some of my personal longevity buddies, we've been exploring the idea of starting up again the longevity party of the United States. And I don't mean a rave or a party. I mean the actual talking politics. Just for some quick updates, there's been a lot of interest, right? Just kind of testing the waters of the community. And so far in the last couple of days, there's been 34 on board in the last 4 days. The only issue is now is it kind of needs to get legs on its own, walk on 2 feet. I definitely need some help from the community and you guys because it's very labor intensive, right? Me to manually talk to so many people one-on-one. So that's it, you guys. Yeah, potential longevity party of the United States. Let me know if you guys have any questions or reactions to that. Thank you very much.
Walter, thoughts?
Go, Didier, go.
Okay, sorry again concerning, so it will be very short. Can you hear me at the moment?
Oui.
Okay, you can hear me. It's already better than nothing. Okay, so once again, very short. Just to... It's not... I cannot believe it. Okay. Okay, so we were speaking a lot about the experiment made by Catcher that actually Hills was paying for this, Hills Healthy Life Extension Society. And when you read this article in The Guardian, it was very spectacular. We said it already, the oldest mice from this group. But when you take a look at the schema of the differences between the tested group and let's say placebo group, the difference is not so big. That's the first thing that I want to say. Well, of course, Aubrey de Grey, for example, was saying, yes, but the placebo group was already living very long. Okay, still. So very, very short again. Concerning what I think is in favor of thinking that plasma is really working. Three things giving plasma do exist since decades, and there are no negative effects known. It seems even that when you go to the literature, it has positive effects to give blood, but the big problem to give plasma, sorry, but the big problem is always healthy people tend to give more plasma, of course. So there was a very successful test with the convoys with very spectacular results. However, when I proposed to the convoys to test on longevity, they didn't want. So this plasma test that was made by the convoys is not really a test on longevity, but it's more a test on healthy results after treatment. And so there was this big and successful test with owl catcher. It was really with what's on longevity. But okay, and cons. So today I was hearing a few people speaking about, for me, anecdotal evidence. So anecdotal evidence is not evidence. When I see people on the video saying I'm feeling better, and when I see the two hands of agriculture, sorry, I'm not convinced. If it has really a big effect, maybe we should know about it already. The trial from the convoys, once again, was not on longevity, only demonstrating better health. And the trial with organized by Owl Catcher was successful for longevity, but with a precise treatment, we still don't know what was happening. And also, there were very spectacular results for health, but less spectacular results for longevity. And that's something I still don't understand. It's like if this plasma was making them young, really young again. But when you take a look at the real longevity, okay, it's going better, but not so much better. So sorry, it was for some reasons I really had no time to prepare, but I'm curious about, for the people who think, I would say the main question for me is, it is so simple to test again with rats. They were so spectacular results. Why? And it costs, I would say, almost nothing, especially for, let's say, people able to pay millions for rejuvenation treatments. Why is nobody going further for tests on rats? Voila. I hope I was more or less clear, and sorry for the technical problems.
Interesting. Thank you. I'm sure there's some thoughts on all that.
No.
You know, I think we have this debate within our Jungian project group, Walter, Stephen, et cetera, about health span versus lifespan. And I think your thoughts, Didier, are looking at these as potentially health span more of an effect rather than lifespan. And I think
Yes.
we're all interested in extending past 122 or 123 years of age at some point. And I don't think we're there yet, but certainly the improvements that we're seeing have great promise for health span, if not eventual lifespan.
DJ, this is Albert. Excuse me. I have a question about whether you have seen or would suggest in the future studies where there is an arm of the trial for people who are regular blood donors.
I'm sorry, I didn't get exactly the question, but anyway, so it was, do I suggest to to make tests with people who are blood donors, I would suggest maybe first to have more look at the statistics that are available now. But my main point for me was to say, okay, testing on rats is so simple, doing what the convoys were doing without killing the rats after a few months is so simple. I don't understand why nobody is doing it.
Can anybody comment on the work that Aubrey de Grey's group is doing? I think he might have dropped out. I don't know if that's towards that end or not. Perhaps not. Any further questions or comments before
I think everybody would agree with Didier that without real data, well, we're really missing the boat. We have such a small amount of data. You know, you can hardly go on the internet without seeing a whole bunch of anti-aging this, anti-aging that, and the other. But where's the data? And even with catcher's rats, what's that? Maybe 9% average lifespan increase, albeit with adequate reliability. But even so, it's okay. I'll take 9%, but it's not exactly a revolution.
Could I say something? So
Sure.
It was mentioned earlier that Harold and I plan to join forces this year. And at the Lundquist Institute, we have an animal colony, and we can do longevity studies there with mice that we can purchase from various sources when they're already old. So perhaps Harold and I will be able to put together another longevity study that's done a little bit more carefully than the one that was just shown, so that we can hopefully break through this discrepancy between health span and lifespan. Matt Kaberlein has been a little skeptical about, the connection between these aging biomarkers and actual longevity. And I think it's a really key point. I think we have to show that these aging biomarkers really, if they really reflect biological age, then they must extend lifespan. And if they don't, then there's something wrong with them. So I do think that this needs to be followed up. It's a very key point. And I think we might be in a position to do that later this year, provided that Harold and I can come up with the funding for it. But Harold has some independent money already, so hopefully we can take care of this.
How much money do you need, Greg?
Oh, not a lot. I'd have to go through the numbers. Lundquist is a little bit costly when it comes to these mouse studies compared to other places, but it's not a vast amount of money. I did run through some numbers for a different kind of study that I had planned before Harold and I decided to link up, and it's doable, but I have to come back to you with an actual number. But thank you for asking that question.
Well, no problem. I'm also offering to help provide some funding through a charity that I have, but it's be a small amount. So what we need to do is if everybody on this call access their wallets just briefly and put in a small amount, you could wind up with almost enough to do half of the study, if not more.
That would be fantastic. My own company, Intervene Immune, doesn't have a lot of money for these things right now, so that every little bit helps.
Perfect.
Thank you.
I'm sorry to say I don't understand. Hills was supporting this study, and it was $50,000. So, for example, Sense, as far as I know, has $15 million. So it should not be a problem. Also, Evolution is supposed to have $1 billion a year. I do not understand why it is not done. I mean, $50 even for one person, it's not so much money. So once again, for Sense, it's like less than 1% of the money that they have in house at the moment. I think 1,500 less about 3%. So okay, it should. And
Yeah,
why also the convoys did never that? I also don't understand, because I was proposing, well, it's the organization reels, but actually most of the money is coming from my pocket, and I was proposing it to them, and they didn't want. That's it.
so they never explained why they didn't want to do it.
Yeah, they explained, we know that it's working, they are in good health, and we want to demonstrate healthy, I mean, we want to demonstrate that all rats can be transformed in healthy rats, but we don't have to prove that they will live longer.
They may have wanted to do something with IP and not be able to take your money. But it's hard to say why. But there's lots of
no. They were proposing me something else where I could give money, so they had no problem to receive my money.
Gotcha.
I think their attitude is fundamentally wrong because the entire concept of life extension is that it's going to happen as a result of health improvement or health maintenance. In other words, increasing health span. They have to go together. So to just assume that they go together without actually proving it is completely wrong. I mean, you have to prove it. It's the basis of the entire argument for life extension. It has to work that way, or we'll never be able to extend life. And if we could extend life and it doesn't work that way, nobody's going to want to, because they're going to be sick and unhealthy. So this has to be looked at head on. This cannot just be assumed away. People will not buy the assumption until it's proven.
This is Albert. I'm sorry, we already have a huge economy devoted to keeping unhealthy people alive longer. Seriously, compared to Europe and other parts of the world where they don't do that. You might get 1 or 2 years of supportive care when you're no longer independent in those countries, and that's the end. And so as a ratio of total lifespan, health span to lifespan is greater in those cultures than in ours. We've spent 20 to 30 years here perfecting the art of building a financially sustainable, well, so far, ecosystem where the incentive is keep people alive in beds, even if their quality of life is long gone. And I think we have to address in our culture how people familiar with aging, whether through their parents or however they became familiar with this culture, they don't want it for themselves. And we can learn a lot by just looking at the other cultures in the world that have a higher ratio already of health span to lifespan, whether they live the same 70 or 80 years, that's an advantage over us that I urge us to look at and try to learn from. Thanks.
Well, we may be buying some extra time with all that money. It's just a very inefficient process. So I wouldn't want to discourage the desire to keep people alive longer, but it's totally inefficient to do it the way it's being done. We have to face up to the fact that dealing with aging is the answer. And the problem is that nobody believes it. I mean, we have all these demonstrations. You heard so much today about the promise, but still nobody believes it. And part of the reason for that is what we just heard about in that last presentation, is that we need a proof of principle. It's like what Aubrey has said for a long time. We need a Methuselah mouse. We need to have a demonstration that we can really extend lifespan in a very significant way. People have been extending lifespan by the order of magnitude that we just heard about in the catcher study forever. I mean, my book lists all kinds of examples of lifespan extension by 10, 15%. The longevity studies with Depernil showed much larger lifespan extensions across 5 different mammalian species. We just haven't really moved the needle beyond all of those initial studies. But we have so many possibilities now for doing so. It just has to be done. So it's not enough just to measure improvements in health. We got to measure improvements in longevity as well, and then show that these things are linked together.
So if one of these studies, one of the patients, a human, lives to beyond 122, or somebody in a clinical program, like my primary physician now is starting up a longevity protocol based on Dr. Kara Fitzgerald's study and book, Younger You. If one of these patients, elderly, lives beyond 122, Does that start to convince the population? Good question.
It does. And I proposed many years ago, when I used to be more active with the LAGRG group, that somebody do a longevity study on centenarians, because those are the people that are at the outer limits of the lifespan. And if you could extend their lifespan, you're pushing the human mortality curve to the right. And that proves something. That shows that you can beat the game. But it's very hard to do a study on these people. They're old and frail, and you know, there are not many of them, and they're hard to find, and they're hard to get to cooperation from, and things like that. But the LAGRG was able to. What's that?
Start with 100 or 90-year-olds. There's a lot more of them. They're obviously different than the supercentenarians who seem to have everything right. They're the ones that just sort of make it to 100 and then keel over. And if we can actually show that the average 100-year-old gets an additional, you know, if you look at everything, the cancer treatment, and they spend billions of dollars for 3 months of additional lifespan of a cancer patient, what is that? Let's how about an additional year or two of normal health? I tend to disagree about the health versus life extension versus health span. I think they're not mutually exclusive. I think there's a large contingent of people who would believe that life extension was possible if health extension was possible. But there's a whole bunch of people focused on length of life, of course. And if you want to know if something actually helps you live longer, you actually have to measure that as the metric. But
yeah. Well,
I want to suggest I believe a pretty cheap experiment that could tell us a lot. Seema is the name of the rat that lives so much longer than her sisters. And I've been trying to get access to tissue samples from Seema. How does the epigenome of Seema compare to the other treated rats who lived many months shorter? And can we build an epigenetic clock based on what we learned from Seema? That's an experiment I'd love to have somebody do. I've been trying to get the tissue sample from Akshay, who has access to it now. I also wanted to ask Chris to reach out to me. I was the statistician in Kara Fitzgerald's study, and I can tell you some things about that.
I would love to. Thank you.
So I put in, I'm sorry. Oh.
I just want to make another real quick point about doing a centenarian study. One of the reasons that people don't do human longevity studies is that it takes so long. So you can do a rat study in 2 years. But once you get to be 100 years of age, your probability of death is 50%. So it would only take this amount of time needed to do a rat study to do a human longevity study if you're doing it on centenarians. Anyway, go ahead.
I was going to put my doctor hat on. And so I'm putting my doctor hat on, and we've done some work with GDF11, just sub-Q injections, and seeing markers change. And I'll just throw a couple that from one particular therapy, one person, and I put a list in the chat. Reaction time improved significantly without practicing or doing anything different. Audio frequency went from 12,800 to 16,000 over 3 years. Wouldn't normally expect that. I'm not saying that caused age reversal, but if we can put together, and my goal is to put together some age phenotypic things that don't change, gray hair, close-up vision, things that we expect to change, maximum heart rate, right? My maximum heart rate is still pretty good, 167, 168 at age 60. So if I see that going to 180, that's pretty huge. And it's not a training effect. You're not going to get a training effect with these type of markers. We take these phenotypic markers, then start to overlay them onto organ functional markers, and then we can overlay them onto omic markers, whatever those might be in clocks. And now we have this triangulation of, and we don't have to worry about aging per se, because if we take someone 3 years and see dramatic phenotypic ages and correlate that, we know we're on the right path. So that's my sort of clinician engineering approach to this. So I'd love other ideas or other markers that would impress people, so I can say these are our goals, and have we hit them?
I'm glad you brought up the training aspect, because over and over I've seen where They will do, whatever, grip strength, how fast can you walk and this and that. And unless you've done that 100 times in a row, at that point you level off. But if you do my grip strength now and do it tomorrow, I'll have a greater grip strength just because I would have mastered how to squeeze the thing a little better. Everybody always wants to do better. So it's really important that people get, I should say this, they should get trained before you start making measurements.
And Rick, I would add.
Yeah, totally. Yeah, go ahead, Howard.
Sorry. I would add, for everybody who wants to measure something useful, the breath carbon monoxide can be measured with CO detectors as small as this just by blowing on them. And that'll give you a direct correlate of your red blood cell lifespan and your RDW.
Is there a good
Can you send us a link?
regeneration? Is there a good, I noticed that I don't heal as fast. And I know that, is there a way of measuring healing capacity to regenerate without necessarily needing a punch biopsy? Because I'd be really love to see, scarless, a little less scar tissue now. The past 5 years, I've gone from healing reasonably well to healing like crap. And I'm not thrilled with that whole situation. I'd like to reverse that. Because young people heal in a day. What used to take me 3 or 4 days to heal is still hanging around a month later for me. I think if you can't affect healing rate and complete healing, scarless healing, fibrotic healing, you're not actually working on fundamental basic aging regeneration. You're just putting band-aids on things or measuring correlations.
Kevin, same measure. Your carbon monoxide level is an index of the healing after any wound, burn, break, bleed, surgery, fill in the blank. It's elevated until you recover, and there's a phase when it rises, and then when it falls, it usually takes longer. And you can measure this in your breath, same for infections if you want to see how long it's taking you to recover. If you're having trouble with healing, though, I strongly advise people to try red light therapy with any red light at 630 or 660 nanometers directly on their skin for 20 minutes a day.
I'm buying a red light bed. Actually, I run a sort of not a clinic, but something for people. But that's why I'm buying it, because I want it for me. But the question really is, how quickly is the wound healing? The infection and all of that stuff is of course really important, but the wound healing, a scratch on my leg that takes 3 weeks to fucking heal, this has got to go. That whole thing, that has got to go.
If you treat it,
yep.
If you treat it partly with red light and partly with now, that's the thing I use to show people. I have some photographic records over time of doing that with a slice in my finger, for example. The part treated with red light heals in approximately half the time and heals without a scar, heals much cleaner.
Fantastic.
Sometimes even without a scab. So you can directly test this the next time you have any bruise or bleed. Just put the red light on part of it consistently, 20 minutes per day per area, and you'll see the results in 3 days.
I will be definitely availing myself of that advice. Thank you, Albert.
Good luck.
Walter, we have a request from Johnny to speak. We may have missed that.
Well, it's not so much a request. I thought I was on the slate.
Go for it, Johnny.
Well, yeah, I can do this in a couple minutes anyway. Yeah, many, if not most of us on this call have known each other for years. So, my mission is to solve aging and just fix it. And then after that, fix a lot of other bad stuff that's going on in the world. So I recently moved to Florida to work on two of what I believe, and it kind of sounds like from what I've been hearing, this group believes are the most important things we can do to solve aging. And one is, I'm not leading this one, but I'm really lucky to be a part of it. It's a Yamanaka OSK gene therapy to reset the epigenome. And that's a few years off before we'll have the results. And I would look forward to talking about that more at a later time. But the other is plasma. And like you, I do a lot of things in my personal age management program, but realistically, I'm thinking it'll just get us a few years and not the kind of reset we're looking for. But I believe that the plasma is the best thing that's available now that will be a bridge to the more innovative therapies, whether it's the Harold Katcher, Akshay Sansvi therapy, or Yamanaka's or gene therapy or whatever. So Walt, would you show that document?
Yes, I will. While you continue
Thanks.
talking, I'll find it.
Okay, well, okay, I thought this was set up, but okay, aginginterventionfoundation.org/JohnnyAdamsPlasmaStudy.pdf. Okay, and I apologize. Normally, I'm not doing this on a cell phone in a car. I just came out of the very important ophthalmologist meeting that took me a couple months to get. So I'm normally at a computer and prepared. But anyway, what this is, I'll just talk it through. It is well, let me first say that some people who know, a lot better scientists than me, by comparison, say that removing pro-aging factors in blood is what's important. Others who know a lot more than me say that adding some youth-enhancing factors are important. So I recently got IRB approval for a clinical trial, and we're going to find out. It's a comparison study between 3 methods. One is therapeutic plasma removal, which TPR I call it, out with the old, in with what is often called as young plasma. I've been advised that phrase, that regulators don't like it. So I use the rather euphemistic, carefully screened plasma from donors in their 20s. That's kind of a mouthful, but I intend to stay squeaky clean as far as regulation is concerned. Okay, the other arm for comparison, therapeutic plasma infusion, just a straight infusion of plasma from young donors. And then the third, therapeutic plasma exchange. And I know we're getting on in the day here. I can wrap this up very briefly. But Walt, if you'd also put a link to that in the chat, and on my website, agingIntervention.org, as soon as I get home, the very first thing, I'm going to put a link near the top of it. But anyway, the third therapeutic plasma exchange, which you're all, after listening to this, very familiar with, out with the old, in with saline and albumin. Now, let me first say that I had one TPE, and my close associates were involved in the first trial. But for me, the TPE produced the best objectively measured results and subjective, but the best results of any therapy I've ever had. Okay. And I've had a lot of different things, umbilical cord plasma, exosomes, and, a lot of stuff over the years. Now, my expectation, this is just my expectation, that removing old plasma and then infusing plasma from carefully screened young donors will have an even greater effect. But that's one of the points to this study. We're going to find out. Just in closing, I'll say my intention is to make this accessible and affordable to our entire community at the lowest possible cost that I can do it. I'm not in this to make money, but I'm an open book. I want these therapies and more of them for myself. So I'm pouring my money into this. So I'm hoping to benefit not only the community, but, myself, my wife, and everyone here. I think that's just about all I have to say. There are a number of I've been working in this plasma arena on and off since about 2015, when it first started gaining attention. And there is a link to a special background summary on that web page that talks about that. It highlights that. And I don't claim to know everything about this. I'm working a lot of things, the technical things, through as I go along, but I do like to think I know kind of a lot and the most important things, and I think I know what I need to know. So two components. One is the actual study. I've been having meetings with doctors with the intention of their offering this to their patients, and also getting the word out for individuals who want to sign up to participate or be study subjects or patients, whatever word you want to use for it. But the other side of it is that I am starting up a plasma collection center. Technically, it's a blood bank. There's a lot of regulations to this. It has to be accredited according to the American Association of Blood Banks, and then there's FDA approval and some others. So the costs, it's going to cost less than $200,000 to start up the thing, which in the grand scheme of starting up initiatives is a lot less than others. But I'm hoping that will be a lot less, maybe half that if we're lucky. I apologize. I do have a spreadsheet. I've spec'd out a budget, but I'm planning for any unforeseen things that I may not have seen of. The overhead on this thing, this is study subject funded. I mean, unless someone with a lot of money wants to pay for your and my therapies, the subjects have to pay for it. My intention is to make it affordable and at the best cost that I can do. So the monthly nut on the Plasma Collection Center I think will be between 34 and 40,000. I'm still finalizing that. So that's all I have to say. Thank you for allowing me to have the floor.
That's great, Johnny. If we want to contact you, what's the best way to do that, to participate in either, personal plasma, treatments or with the center?
Well, 3 ways. Just pick up the phone, call me. The best number, well, the official number, well, I'll just give you my personal cell phone, 949-922-9786, or email jadams@agingintervention. WhatsApp also works at that 949-922-9786. And let me just say, I'm on this pathway, but I want to partner with others. And if someone else has a better way, hey, I'll work with you on your plan. I'll help you facilitate this. I just want to move it ahead.
Note that I have put the link in the chat box to that'll give you all Johnny's information, plus a summary of what he's doing, some of the stuff he's doing.
Yeah. And in that write-up, there's a lot of details. If we're going to have some form of close working relationship, I'll send you the IRB protocol and any other questions.
Yes, Johnny, this is Albert. I'm curious if you could add an arm of regular blood donors to see where they are starting and what happens to them after they give just a straight up blood donation. Which hopefully there's a way to add without a lot of cost, because hopefully there's no extra cost for their procedures, which are free, right?
Well, right. Yeah, there would, I believe there'd be no extra cost to add it to the IRB and to the protocol. I would look to someone maybe like you to help manage that. I also would share. Actually, I'll share with anyone the biomarker set that is not on that document. It's it's like biomarkers are my middle name, and you can't manage what you don't measure, and the most complicated thing, in my estimation, in the world is aging. So you have to, too many of these clinics, they go for treatments and they don't really do any measures. But we have some, I believe, pretty good, very good, but relatively low cost biomarker set. But you would be free, to do your own, anything and everything that you want. So
I'll
there's
definitely
that.
follow up with you about that. And I used to be a clinical study coordinator at Hopkins decades ago, and I thought I was done with it. It's a miserable job. But I'm
They
happy to
keep
help if I
calling you
can.
back in. Yeah.
Johnny, I'd
Yeah.
be honored to, this is Josh, I'd be honored to be a statistician or on the statistics team for your study.
Thank you. That would be a big help.
If you're going to be doing regular bloods, we're learning about so many biomarkers that are really useful that people are already getting in their CBCs, like the RDW. And I'm confident if we set up the study protocol correctly in advance with Josh's help, just fill in the blank at the end to get the results.
Well, okay. Now the protocol, the IRB has approved it. This is an IRB approved study, but they're open to modifications. They're working with me on this. Oh, I do want to rewind to one important thing that I forgot that relates to some things that were discussed earlier. The TPE, I told you, yeah, best results ever, and let's see what happens with removing, my old plasma and infusing plasma from young donors. But the results, the different biomarker tests, and admittedly I did a short test, but they're very relevant. They faded after maybe a month. Okay. And actually the exercise stamina for me, which was outstanding afterwards, faded after about 10 days or so. So this is unfortunately the kind of thing that I believe, anyway, based upon the experience I've had and talking to others in the community, that well, like I mentioned earlier, is will require repeat treatments. And unfortunately, opening a plasma collection center, it's with all the regulations, isn't it? It costs money. I wish to gosh we could just do this without regulation, but unfortunately, to do it, we and stay out of trouble, I'll say, it has to be under a particular framework. And if you know of going offshore, yeah, I'm all for it. And yeah, Roatan, I love the place. Never been there, but gotta go. I'm all for a lesser expensive, lesser convoluted way of doing this offshore. So if you have a plan, let's talk. And Rick, I really want to connect with you later.
All right. Shall we wrap up?
Yeah.
Stephen?
Plasmapheresis and plasma exchange, they seem to be pretty safe. That's my first takeaway. Second takeaway, although by no means scientifically proven, they may provide a bridge for some of us. And we're going to learn a lot in the meantime. Dr. Stickler and Garrett have been hanging in there with us for quite a while. I appreciate you guys helping us out by telling us what's going on in your Austin clinic with real patients. The Youngin group, I think I'd be remiss if I didn't mention that Dr. Giuliano is my mentor, and I think I can safely say he's a mentor of other members of the Youngin group. We're dedicated to rejuvenation, human rejuvenation, not mice. Yes, we want to improve health span, but we're for rejuvenation. And I think Walter, Chris, Albert, Rick, Dylan with Derek with everybody with the Youngin group has worked hard to put this together, and it's been a real joy to see all the contacts we've made overseas and in the U.S. with the leaders in the longtime leaders in the longevity movement. Anyway, we appreciate it. We really do. Thank you so much.